Okay, so this is the second video in our three-part series about solving linear equations in two variables, and this time we're going to talk about doing it algebraically. In the last video we solved just by graphing, and we saw that we always ended up with one solution, infinite solutions, or no solutions. This is still going to be true here, but now we're doing strictly by algebra. So we can use substitution or elimination. Those are the two methods. In example 5, we're going to use substitution. Now substitution, what we want to do first is get one of the variables x or y by itself. Then we're going to take that value, that expression that we get for x or y, it doesn't really matter which one, and plug it into the other equation. And then we'll just go from there. So what I'm going to look for first, anytime I'm trying to use the substitution method, is there a variable that's already sorted by itself? And I can see in the second equation, I have one single x. So it's going to be very easy to get by itself. So that's going to be my target. So I'm doing my scratch work in blue. So x plus 2y equals 2. So I'm choosing to get x by itself. You can choose to get y by itself. If you do the process correctly, we should end up with the same answer. So I'm going to say minus 2y on both sides to get x by itself. Cancel out, so x equals 2 minus 2y. Now what this means is everywhere that I see an x, I can replace it with 2 minus 2y. It's kind of like first name, last name. You could call me by my first name, or you could call me by my last name. Okay, so now what I'm going to do, since I used the bottom equation, I have to now use the top equation. Okay, you don't want to plug back in. You don't want to substitute into the equation that you just used. So I'm going to substitute into the one I haven't used yet, which was the top. So I have 3x plus 4y equals negative 4. But now, instead of x, I'm going to substitute in my 2 minus 2y. Now, there's more than one thing here, so I'm going to put it in parentheses when I substitute it in. So I have 3 times 2 minus 2y plus 4y is negative 4. Now I'm just going to clean it up as much as I can, and I'm going to solve for y, because that's the only variable remaining. I have distributive properties, so I'm going to do that first. So I have 6 minus 6y plus 4y equals negative 4. I want to combine terms, so I have 6 minus 2y equals negative 4. And now start getting y by itself. So I'm going to say minus 6, minus 6. Cancel out, so negative 2y equals negative 10. And I want to get y by itself, so I'm going to divide by negative 2 on both sides. Cancel out, so I have y equals negative 10 divided by negative 2 is positive 5. So now that I know that y is 5, everywhere I see a y, I can plug in. Well, I'm trying to figure out what x is. But hey, I already got x by itself. So now here, everywhere I see a y, I'm going to put in a 5. So I'm substituting again. So x equals 2 minus 2 times 5. Clean it up. So x equals 2 minus 10. So x equals negative 8. So my solution, or my ordered pair, is negative 8 comma 5. That's my answer. So there is only one solution here. Okay, pretty easy. Example 6, we want to use elimination. So if you prefer substitution, that's fine, but I would encourage you to know both methods, substitution and elimination, because sometimes in some situations substitution is easier, in other situations elimination is easier. So what we want to do in elimination is we want to pick what variable we want to eliminate, so either x or y. Again, it doesn't matter. It's a personal preference. And what I need to do is to make sure that the coefficients are opposites. So if I have 2 x's on top, then I'm going to need negative 2 x's on the bottom to cancel them out. Okay, so what I'm going to do is I'm going to choose to eliminate the y's. You can choose to eliminate the x's. If you do it correctly, we should end up with the same answer. So what I'm looking at is the y. I have negative 4y on top and negative 5y on bottom. Unfortunately, those are not opposites yet, so I have to do a little bit of scratch work. What I'm going to have to do is to multiply each equation. And I'm going to think about what's a multiple that negative 4 and negative 5 both have in common. And it's 20. 4 times 5 is 20. So I will need one of the 20s to be positive, one of the 20s to be negative, but I want 20y for each one. So I want to say my top y is going to be positive, and I want to keep my bottom y negative. Again, that's preference. So to make my top y a positive 20y, I need to multiply by negative 5, the entire equation. And it's very important that you multiply the entire equation. If you don't, it's not going to come out right. So multiply by negative 5 on top. And it's kind of like distributive property. So I end up with negative 5 times 2x, it's negative 10x. Negative 5 times negative 4y is positive 20y. And then negative 5 times 13, well, let's use calculator, but I think it's going to be negative 75. But I'm going to use calculator just to double check. So go to my main screen, negative 5 times 13, negative 65. So I was close, but again, it's a good thing I double checked it, otherwise I would have had a problem. All right, so I did all the work for the top equation. Now I need to do some work for the bottom equation. Since I have 20y up top, I want my y on bottom to be negative 20y. The only way to make that happen is to multiply by positive 4. And again, I got to multiply the entire thing. So 4 times 4x is 16x. 4 times negative 5y is negative 20y. And then 4 times 8 is 32. Now you can easily see that my y's are opposites. I have positive 20y and negative 20y. That's exactly what we needed to happen since I chose to eliminate my y's. To eliminate the y's, what I'm going to do now is to add. I'm going to add these two equations together. X's go with x's, y's go with y's. Regular numbers go with regular numbers. It's really that easy. So negative 10x plus 16x is 6x. 20y minus 20y is going to cancel out. Equal sign just falls down. And negative 65 plus 32, I think, is going to be 33. But let's use calculator again. So negative 65 plus 32, negative 33. And then finally, I want to get x by itself, so I'm going to divide by 6 on both sides. So x equals negative 33 over 6, but I'm going to use my calculator, and hopefully this comes out nicely, maybe not. When I get negative 5.5, I want to turn that into a fraction. That becomes negative 11 halves. So if you get a fraction, you always want to reduce it as far as you can. So x equals negative 11 halves. Now that I know what x is, I can go back to my original equations. 2x minus 4y equals 13 on top, or 4x minus 5y equals 8 on bottom, and plug in. Everywhere I see an x, I'm going to plug in and then solve for y. I want to plug into the top equation. Again, that's just a personal preference. I typically, in my own work, plug into the top. Just a habit. If you want to plug into the bottom, it should be okay also. You should end up with the same thing that I end up with. So I'm going to plug in the top. Everywhere I see an x, I'm putting in negative 11 halves. So 2 times negative 11 halves minus 4y equals 13. Now I'm going to clean this up. Well, you should know that 2 divided by 2 cancels out, but if not, just use your calculator. No shame in that. So 2 times negative 11 halves will be negative 11. I'm just checking my calculator, and I was right. So negative 11 minus 4y equals 13, and I want to start getting y by itself. So I want to say plus 11 on each side. So negative 4y equals 13 plus 11, so that's 24. Now divide by negative 4. So y equals negative 6. Okay, so I have my 2 points of intersection. My 2 values for each variable. So that means my 1 point of intersection for these 2 lines in my system is going to be at negative 11 halves, comma, negative 6. Again, fraction's okay, positive, negative, that's okay, decimal's okay, but this is my solution right here. Its solution is always an order pair, one solution or no solutions. Okay, in example 8, I want to solve. I can use any method I want to. I can use graphing if I want to. I can use substitution or elimination. It doesn't matter. What I am going to do is look at this system real quick and try to figure out which one's the easiest to use. Automatically in the top equation, I see an x that's essentially by itself. So that tells me substitution is probably going to be the easiest thing to do. Okay, so that's what I'm going to do. If you want to use elimination or you want to use graphing, that's totally fine. I'm going to do my scratch work for the top in green. So x minus 2y equals 3. I'm going to get x by itself because that's what I'm going to choose to isolate. So plus 2y plus 2y. So I have x equals 3 plus 2y. All right, that means everywhere in the bottom equation, again, I'm using the bottom equation since I started off with the top. You cannot substitute back into the same equation that you just worked with. So everywhere in the bottom equation I see next, I want to plug in a 3 plus 2y. There's more than one thing here, so when I plug it in, it has to be in parentheses. Otherwise, you're going to get the wrong answer. So I'm going to do the bottom equation in blue. So I have 2 times, I see an x, I'm going to plug in 3 plus 2y minus 4y equals 7. Now I want to clean up as much as I can. I see distributive property. So I have 6 plus 4y minus 4y equals 7. And I want to keep cleaning up. 4y minus 4y is going to cancel out. So I have 6 equals 7. Well, hold on. My y's disappeared. That's not good. Since my y's disappeared and I end up with this thing, 6 equal to 7, that doesn't make sense. 6 is never equal to 7. So this is never true. And there's no variable left. So the fact that there's no variable left and this 6 equals 7 is never true, that means no solution. If I graph these two lines in my original problem, got y by itself and graph them, that would mean these are parallel lines. Okay, so just graphically, that's what it would look like. Example 9, again, I can choose whatever method I want to. It doesn't really matter, okay? Could do graphing, could do substitution, but I think I'm going to do elimination. If you ever do graphing or substitution, that's fine. We should end up with the same answer in the end if you do it correctly. All right, so elimination. Since I eliminated it a couple examples ago, I eliminated y's. This time I'm going to, I think I'm still going to, no, I'm going to eliminate the x's this time. So I want to think about, well, what do they have in common? 6 and 15. Nothing that I really know, so I'm just going to multiply 6 times 15 and figure out what that is. That's probably going to be my least common multiple. It might not be, but it is a multiple that they have in common. 6 times 15 is 90. So what I'm trying to do for my x's, since that's what I'm going to target to eliminate, is I want one of my x's to be positive 90, the other x to be negative 90. Okay, so what I'm going to do, again, I have to multiply. So I want to multiply the top equation. Let's go ahead and call that positive 90x. So I need to multiply the top equation on everything by 15. All right, so I have distributive property now, sort of. So 15 times 6x is positive 90x. 15 times negative 10y is negative 150y. And then 15 times 12, ooh, I don't know what that is. 160 maybe? I don't know. I'm just guessing there. 180. So I was close, but definitely not close enough. All right, so now I need to do the same idea with the bottom equation. This time I'm going to multiply by positive 6 because I want my x to come out to be negative 90. So 6 times negative 15 is negative 90x. 6 times 25 is, let's see, 6 times 25. I think that's 150, but again, I'm going to double check it. It's positive 150, so I got that one right, so that's good. And then 6 times negative 30 is negative 180. Okay, so now that I've multiplied those and my x's already are opposites of each other, positive 90, negative 90, I want to add my two equations together. And as we expect, the x's eliminate each other out. That's good. But now let's go to the y's. Negative 150 and positive 150. Wait a second. That's eliminated. And then finally 180 and negative 180. Those eliminate. So I have 0 equals 0. No variables. But at least this is true. I know 0 is equal to 0. That's always true. So no matter what, I know 0 is equal to 0. But there's no variable left. So what that means is infinite solutions. So when you have something like 0 equals 0, 1 equals 1, 100 equals 100, something that's equal to itself, that means there's infinite solutions. And graphically, if we got y by itself and graph these, this will be the same line with infinite points of intersection. That's it for this video. Again, as always, if you got questions, please let me know.